Would you please tell me where sine of 330 would be found in this circle? Oops, I didn't want to make that circle. Sine of 330. Well, first of all, 330 is kind of close to 360, so I hope you know it starts here, goes all the way around to 330, so it'll be like that. Maybe that's a little small. Try that. And that leaves how much left for the reference angle? 30. So if I asked you for that, it's really just as if I asked you for the sine of 30. Now you got to know what the sides are. And the one across from the 30 is a 1. It's a really good thing to know. Then you can kind of fill in the other ones. The longest side is the one that's double, and that's 2, and that's the hypotenuse. And then the other one's square root of 3. So sine of this is opposite over hypotenuse. Opposite hypotenuse. 1 over 2. Answer is 1/2. Oh, good question. Is it negative or not? Is that 1 negative? You sure? Okay. And then how about that 2? How do you know that the 2 isn't negative? Hypotenuses are always positive, so you are correct. It should be negative 1/2. All right. I wasn't checking you. I just forgot the negative. And that's going to happen to you, too. It's really easy to forget. And remember, we let you make a dumb mistake like that out of 4 problems. But if you make a dumb mistake on every problem, you're going to not pass. All right, so try to be careful on those negatives. It's a good point. I didn't catch it. You try to not mess that up. Okay. Well, if I asked you the question this way, sine of theta is 1/2, that's different, right? In this case, did they give me the sides or did they give me the angle? Give me the sides, so they want to know the angle. And most of you would say, well, the answer is 30, because I've got that one memorized, and we just did it 2 seconds ago. So you're right, it's 30. But then you'd put down 30 on your paper, and then you might even be smart enough to check the directions to see if it wanted radians or degrees. And if it wanted radians, what would you put? Pi over 6. But a lot of you would have stopped right there, and maybe you wrote both of them down, and it'd be wrong. Can you tell me why? Yes, sir. Oh, nice. There's 2 spots where sine of something would be 1/2. Okay, so there's 2 places. What do I mean by that? I'm going to show you the normal spot where sine of 30 is 1/2. That's like this, where you go, boop, and this is 30, and that's 1, and that's 2, and that's square root of 3. Does that make sense? That's the first one. But where's the other one where sine of theta is positive? This is important. Positive 1/2, because there's another spot where it's negative, but that's different. Where's another spot? Yes, sir. In the back. 5 pi over 6, also known as, well, a whole bunch of 180 minus the 30, which would be 150. So at 150 degrees, also known as 5 pi over 6, there's another triangle that would give you the sine of 30. So there's almost always 2 answers to today's problems. I'll give you another one that's like that. So just to clarify, the final answer for this is 30 degrees was the right answer, unless they wanted it in radians, in which case I would say pi over 6. And then another right answer, though, is 150 degrees. And that, if they wanted it in radians, it would be 5 pi over 6. All right, so let's try another one like that. How about cosine of something is 1/2? Would you figure out what the 2 answers are for that one? Draw your pictures. The first one's an easy picture. Second one takes more thought. And it's harder to figure out that angle then. Tell some of your thinking, which is good, but actually write the triangles. Make yourself 2 triangles. I'll give you a hint. That ASTC, all students take calc thing, that's really handy. That's why I was saying you probably should, from now on, when you make your circles, do the ASTC thing. Why? Because didn't I just tell you that cosine has to be positive? See, because cosine's 1/2, and that's positive 1/2. And if cosine is positive, I know that I can't be here and I can't be here. I have to be in one of those 2, see? That's how you know where your 2 triangles should go. Those are the two quadrants where I got to draw a triangle. So I draw my first triangle like this, and this is going to be, well, if the cosine's the adjacent over the hypotenuse, this must be a 1, this must be the 2, and this must be the square root of 3. So this must be the 30-degree angle. So the angle in question is 60. Raise your hand if you had 60 as one of your answers. Good. What if it was supposed to be in radians? Then what would you say? Pi over 3. All right. Then, how about that other spot? I'm going to erase my red triangle. I'm going to get that out of there. And I'm going to make the other one. Now, yeah, I would, if I were you, I'd have both triangles on the paper, but just to make it easier for you to see what I'm drawing here. Here's my other triangle. And in my other triangle, same deal. I've got to know the cosine, the adjacent over the hypotenuse are 1 and 2. And then the other side must be root 3. And then I know that the one that's across from the 1 is this angle. That's the 30 is across from the 1. And it can be confusing because the way I drew it, it doesn't really look like that's 30 degrees. But if that's 30, this must be 60, but it's not 60. You can't say the answer is 60. We already said that one. It's all the way around here. So it's 360 minus the 60. So did you say 300? Raise your hand if you had 300. Okay, good. And if you had to have that in radians, let's say you blank out and you're like, I can't do this. I don't remember how to, what the radians would be for that. Just multiply it. What would I multiply it by to get it into radians? Pi over 180. And then you got to do a little reducing, but it won't be that bad. Cancel the degrees, cancel the 0. 30 over 18, and that would be 15 over 9. So 15 pi over 9. Is that done? No, it's close, though. Got to go one more step. 5 pi over 3. Final answer. All right, so there's two answers again, and there's pretty much always going to be two answers. Now, I know you might be thinking, how am I going to remember that there's two answers to these questions? In the directions will say, find all angles where 0 is less than theta, which is our angle. Actually, they say find all angles theta such that 0 is less than theta is less than 2 pi. And actually, it says less than or equal to 0. So 0 is an okay answer. But is 2 pi then an okay answer? No, because it says less than 2 pi. So you could say 0, but you wouldn't want to say 2 pi. All right. This is the hint that this kind of question has two answers. Do you get how when it says find all angles, it's kind of a hint that there might be more than one? And actually, and we get into really hard problems, I've seen problems that have up to 6 right answers. We aren't there yet, don't worry. But for right now, be looking for 2 angles that'll work. All right, here's one that stumps people a lot of times. Sine of this angle is equal to 1. It's equal to 1. Isn't it normally something over something? Put 1 over 1, okay. So then, draw me a triangle that would work for that. How could you draw a triangle that has an opposite of 1 and a hypotenuse of 1? You couldn't, could you? So that means you can't draw a triangle, which is a big hint. No solution. Where are those places where you can't draw a triangle? There, or there, right? So if I can't draw a triangle, then I got to go, oh, this is one of those kind where I have to use that thing with the points. What was that thing with the points again? Okay, it's this point right there is 1, 0. This point is 0, 1. This point is -1, 0, and this point is 0, -1. Please stop talking. All right. So if sine is equal to 1 over 1, then stop talking. It's distracting me. Sine is y. Do you remember that? Sine y? Sine y. All right, so sine's y. Where is y equal to 1? There's 2 spots, right? Is y equal to 1 in that spot? No. X is equal to 1 there. Is y equal to 1 in this spot? Yes. Y is equal to 1. Be careful now. Is y equal to 1 in that spot? It's equal to negative 1. All right. So doesn't it look like there's only one answer? Is that okay? If there only is one answer, then that's okay. Seemed like there was going to be two, but that one doesn't qualify because of that negative on there. And now let's look at the picture. And Mr. Winterhalter is going to be teaching you this next week. But if you graph sine, it looks like this. Starts at 0, and sine has nowhere to go but up. And then it goes back down again, and then it comes back up again. And if we're supposed to only be between 0 and 2 pi, this is where 0 is, and this is where 2 pi is. If I'm only supposed to be in that zone, do you see that sine is only one time? Right there. That's where sine turns into 1, because it's got a height of 1. It isn't 1 any other time between 0 and 2 pi. So it's okay if it's only 1 once. How about if they want to know when it's 1/2? Is sine 1/2 more than once? Yeah, it's 1/2 here and it's 1/2 there. It can be 1/2 twice. Will it ever be something 3 times in between 0 and 2 pi? No. 2 times is the most between 0 and 2 pi. All right, so can you have only some answers will only have one answer? Yes. All right, let's do another one like that. That's kind of weird. Where is tangent of theta undefined? Think it through. Think about those points. The ideal circle that you could draw every time would have ASTC, and frankly, it would also have the quadrantal numbers, but I wouldn't probably put them in until I figured out that, oh, this problem is one of those, where it's 1, 0 here, 0, 1 there, negative 1, 0 there, 0, negative 1. All right, figure out that one. Where's tangent of theta undefined? So undefined means that it has a 0 where? On the bottom. And what is tangent equal to? What over what? Y over x. So really, we want x to be 0, right? Is there any spots where x is 0? Yes, there is. This is the spot where x is 0, right? So that's one of my answers, which would be pi over 2, or 90. Depends what they want. If they say between 0 and 2 pi, that's a hint that they want, what do you think? They want radians. If they say between 0 and 2 pi, you're supposed to give the answer in radians because the directions said 2 pi, which is in radians. Same deal, if the directions are in radians, you should give the answer in radians. Make sense? Okay. All right, so this one I really should answer as pi over 2. It is true that it's also 90, but since the directions will be in radians. Then where's the other spot where x is 0? How about this? Is it okay if it's negative 1 divided by 0? Is it still undefined? It is. So there's 2 answers for this one. And that's pi over 2, and this is pi over here, but what's that? What do they make that one? 3 pi over 2. So the 2 answers are pi over 2 and 3 pi over 2. And the hint you look for is you look at the directions, and the directions say find all the angles that are between 0 and 2 pi. There's probably 2 answers. Sometimes there's still only one, though. All right. Then there's some simple ones like find the sine of 495 degrees. It's really not that bad. What is the first little math thing you should do to solve something like that? Change the 495 to something better by doing what? Subtracting 360. Good idea. Then it'll be a smaller, because 360 means go around the circle and then start over again, right? So I'm going to subtract 360. So 5 miles, this is going to be a pain. What is it? 135. And I can, now that I got that, it's easy to double check. You just add these together and make sure they make 495. And they do. Good. So 135. Where is that? You'll start recognizing that that's a bunch of 45s. So you go 45, 90, and another 45 makes 135. So it's right there. So what's the sign at that spot? Well, I got to figure out what the sides are. But if it's a 45-degree angle, it's a 1 and a 1 and a square root of 2, and I made a mistake. What was it? It's supposed to be a negative 1 right there. And then, if this is the angle in question, what's the sign is the opposite over the hypotenuse, and it would be opposite. Which one's the opposite side? 1 over hypotenuse square root of 2. 1 over square root of 2. Any questions? All right. Those are nothing really new there. It's just they give you ridiculously big angles. Like one of your questions asks you to do 870. So you do 870, you just subtract off a couple of 360s, and it won't be that big of a deal, right? Do you have to be able to do this in your head? Yes, there's no calculators. So you have to be able to subtract. Ooh, scary. If you can't handle subtraction, you shouldn't be getting good grades on your pre-calc tests. Okay. One more topic. Would you agree that's the same exact thing as sine of 30? So do you have that one memorized yet? What is it? 1/2. You could make a helper triangle, but that's a slow way. I told you should memorize it a long time ago. It's already come up like 4 times since then. But anyway, sine of 30 is a half. So the answer is a half. True. But what happens if I do this to it? Sine of 30 plus 2 pi. Do you get how when you add 2 pi to you just go around the circle and you'll be in the same exact spot you were in? So isn't the answer the same exact thing it was? Yes. So if they add 2 pi, your answer is still going to be a half. Because you're just in the same exact spot. You were at 30 degrees, which is right here. Nope, I missed. Right here. And then you go all the way around the circle and you come back and you're in the exact same spot. So of course the answer is the same. How about if I added 4 pi? Same exact answer, right? Or 6 pi or 8 pi. Okay, I think you get the point. If it's an even number of pi's that they add, then you don't have to worry about it. It's like it didn't happen. Okay, so that's one possible scenario. The other one is you add just a pi, exactly. Now, if you add just a pi, that's going to bring you exactly to the other side, and you'll be drawing your angle over here. So now, if it was pi over 6, I kind of did that badly. If it was pi over 6, that means this angle is 30 right there, right? So if I draw this like this, these are vertical angles, it's called, so that should also be 30. So shouldn't it be the exact same thing? You know what I mean? It's still a 30-degree angle. So if I draw this little triangle, if this is a 1 and this is a 2 and this is the square root of 3, so what's wrong with my thinking? This is a negative and this is a negative, and so therefore the answer isn't a half anymore. It's what? Negative a half. All right, so when you see questions look like this, don't freak out. It's just like figure out what sine of pi over 6 would be, and then you got to move it to the other side of the circle because of this, plus pi. You probably wonder what that was when they're listening at home. Okay, so anyway, if I had added 2 pi, remember, the answer would have stayed exactly the same. If I would have added 12 pi, exactly the same. How about 13 pi? Go to the opposite side. All right. Yep. It's forged 3. All right. Cool. I think you know everything you need to know. And sadly, that's probably the last thing I'll teach you until sometime Tuesday of next week. All right. Here you go.
Where are you going?
I'm going to the island of St. John.
Oh, yeah.